Okay, so today is the class number 2. We're going to talk about NumPy. That's statistics with Python. So last time we didn't finish our work on class number 1. So what we're going to do on this class, we're going to do some revision on coding. And then I'm going to talk about NumPy. And then after that, we'll talk about statistics. Like how do we use statistics in data science? Okay. Did you guys have a chance to look at the question on class 1? Remember last time we stopped here. So we need to solve the maximum, mean and minimum without using any Python functions. Have you guys have a time to work on it? Okay. Okay, probably too busy to work on this. So last time I did the maximum. How should we do the minimum? How can we use mean or a loop or if functions to find the minimum of a given list? Any clue? Any idea? So, okay, no functions are allowed to solve these questions. Okay, let's say we have a list. Okay. Let's say we have a random list called X. Okay. Okay, so list of 5. We have 5 numbers in the list. Alright, without using any functions, we have to make use of a loop. Okay? So basically the logic is you loop through the entire 5 numbers and check it one by one to see if that number is smaller than the previous one. And how can we do it? So let's say we have X and we define a new variable called M. Say M equals the first item in X. Alright? Okay, so now M is 13, right? What we can do is we can loop through the entire list for I in X and check if I is bigger than M, actually smaller than M. Then you replace M with the value of I. And then you print out M, that's 2. And you can check it by using the function. Okay, minimum of X is 2. Okay, how about for mean? How can you do it for mean? Any idea?
Make a sum.
Make a sum.
Make the sum of every items.
Yeah.
Right.
But sum is not allowed.
Or you can just look through the list and keep adding each item and then divide by the
length of the list.
Yes. Yeah, that's more or less your idea, but just to make use of the loop. Okay, so how can we do it? Again, we use X. We define a function, a variable called M, and get the first item. Okay, and then for I in X, then what should I put in here? If I want to keep on adding, okay, we can do M plus equal I.
Wait, why are we using
Plus equal.
It's because this represents M equals M plus I.
Yeah. Basically, this is a a funny Python syntax, m plus equals 1 equals to m plus m equals m plus 1. Okay, that too is the same thing. Yeah. So if you run these functions, you will have m. Okay, m is 87 divided by the length of x. It's gonna get 17.4, and you can check it. Mean of x. Well, actually, you can't do it this way, but you have to do it with a library called NumPy. Okay, which we are gonna go through today. If you do import NumPy as np, and you put np.mean. Okay, I made a mistake. Okay, because m shouldn't be the first item. M should be 0. Okay. Does it make sense to all of you? Yes.
I don't understand why n equals to 0.
Okay, so okay, we have a list of 5 items. Okay, and what I want to do, I want to loop through all of these items and sum them together. If I didn't define anything as m, say m is, let's say I don't use m anymore, I use n. But if you do it this way, because n is not defined previously, you can't use this function. Because this function essentially means n equals n plus 1. Right? And if you have n in here, and you didn't define it, it means Python don't know what you're talking about.
But why sometimes we use n equals to 0 and then the other time we use n equal to x branch 0? I mean the first.
Oh, this one.
Yeah.
This
what
one.
What is the difference between the 0 and then the first item in x?
Actually, what does this mean? This means
first item.
In x, right?
Yeah. So you would count the first step.
Okay, for this case, because if I do it this way, if I do it m equals the first item in x, I'm going to count it twice, right? So if you look at the list, I define m equals 13, okay? But I'm looping it from 13. So first item will be 13 plus 13, and then it will keep on adding. So that's not the right thing to do. You have to skip the first one and keep on adding. I hope it makes sense.
Just as a quick question, because normally when we start with like m, for example here, m equals to x of 0, right?
Yes.
That is to say that the first number, m's first number is the x of 0? Like
M is the first item on the list.
Yeah, and then we would define it as 0. Like we would just give it a number, like that's our first number on the list.
Yeah, basically it's just a first case.
Yeah, but because I'm just sort of confused because normally what that happens would mean that, like, for example, the reason why we put it here is because we want to have a starting point.
Yes.
But wouldn't that, like, if I was to show it, wouldn't that be the first, like, what if I don't want, like, that first number? Because in this example, we need to have it just so we can start the loop. But what if I just want to start, for example, I don't know, like, never mind, I think I'll have to repeat what I'm trying to say.
Yeah, I think this is a weird example, okay? Because normally we don't have to write the functions to find the mean. Okay, this is just like a practice for you to make use of loop. Okay, the whole point for this is you know how to use the loop to loop through every item. Okay. Well, you can choose to start with 0, or you can choose to start with the first item. let's say for this case, you can do this as well. But then for the loop, we can start this way. Just start the loop at the second item of x. Okay, it should give you the same results. Okay, I hope that makes more sense. So this means I start in here and I start looping 27 to 23 and 9. Okay, or I can start with 0 and I loop through all of them. Does that make sense for everyone? Okay. Oops. Okay. And then the next thing, we talked about functions, right? So I'm gonna skip through functions. Okay, in here we have exercise, which is construct a function that returns all the divisors of the number the user input as a list. Okay. Do you guys want to give it a try, or do you want me to demo it in here? Okay, let's say you are given these questions. Construct a function that return all the divisors of the number the user input. Okay, how would you do it? Okay, the user can input every number, right? So okay, let's say the user can input a number called x. Okay, and x can be any number. It can be like 10 or 100. Okay. So what's the logic? The logic is I have to find out the range of number that it can be divided. Okay, but that number can't be bigger than itself, right? So if the user input 10, you're going to test from 1 to 9 or 1 to 10. Then we have to come up with a list range from 1 to 10. And this can be done this way. You put list and range. Okay, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? But 0 can't be a divisor, right? So we have to start with 1. And then you do it this way. 1 to 10. Okay, now that we have a list, what should we do? What have we learned? We learned how to use a loop, right? So you can do it this way. For I in the list, okay, then what should I do? Because what this is doing, every single step of this will be 1, and then 2, and then 3, and then 4, right? Okay, then every step we're going to check if it's a divisor. And how should we do it? X divided by, okay, let's do A equals X. Okay.
We can check if A is integer, then
Okay.
it is the divisor.
Okay, how do you check if A is a whole number? Percentage. Okay, and how should I do it? A percentage I
Equals
0. So it will be an if, right? Then what should I do? Just print it out. Okay. Print I, right? Okay. It's giving us an error or because x is not defined. Okay, I think the right answer should be 1, 2, 5, and 10. Okay, so this is not a perfect solution. And let's say if we stuck in this point, the obvious to do is print out A. Okay, and to see what's went wrong. Okay, so A went through this process, x divided by I. Okay,
Oh, we have to put the 10 inside A. No,
No, sorry.
Create this
create a list.
like an empty list.
Actually, okay, I'll tell you what I would do. We can do it this way. So for I in list range 1 to 11 or 1 to x, and then if x I equals 0, print I. Okay. Okay, that's the solutions. Okay, because x percentage I is 1. Okay, this percentage means residual. Okay, if there's a residual, then this won't be 0. So that's the right way to use these functions. Okay, but this is not the end of the questions. What we need to do is to put everything inside a list. Okay, do you remember how to put things inside the list? Okay, you can do append, but we have to do one thing before append. Yeah, you have to create an empty list. Okay, let's say I create an empty list called L, and I do L dot append. And now I will have a list of residuals. Okay. Any questions in here? Okay, so it might be confusing at first, but you know, if you try it a few more times, it should start to make sense. Okay. So I'll send you guys the solutions afterwards. Okay, so well, I received some solutions for Hangman that some of you guys said on your previous Python class you've done Hangman already. So okay, I've got some extra challenge for you. If you've done Hangman, you can do this alternative problem, which is find the maximum subarray. Okay, this is actually an interview question for my firm. And what you are expected to do is you're given a long list, and you have to find the combinations in array that give you the largest sum. Okay. And basically in this example, you're required to give the answer of this 4 minus 1, 2, and 1, because the sum of this gives you the highest sum. Okay. And you can make use of your loop or your if functions to try to find the solutions. Okay. So that's it for the remaining of last class. Okay, so now let's go back to lesson 2, and we're going to talk about NumPy, and then we talk about statistics. Okay. Alright, so we're gonna talk about statistics with Python. Okay, the first question for you guys is why statistics is important? Why does it relate to machine learning or data science? Okay, there's a okay, very nice visualizations here. Okay, let's say I'm playing a game with you. Okay, I'm gonna play dart with you. Right, if I'm a very experienced dart player, I'm gonna reach this, right? Because I'm more experienced. And let's say if you don't have any dart experience, you're gonna play like this, right? Okay, so if you plot out the distributions, mine would be something like this. Okay, because mine is more accurate and is closer to the mean. Right? Does it make sense? And then maybe your distributions would be like that. Because even though you're aiming at the center, all your points will be scattered around. So your distributions will be like that. Okay, let's say now we have a world champion in dart. What's his distribution will look like? World champion.
Precise.
Closer to the center.
Sorry?
Closer to the center.
Yeah, closest to center and probably higher up like this. How about the worst ever player in dart?
The line will just drop lower and lower.
Yeah, it's gonna drop until it's very, very flat. Okay, I hope that makes sense. Okay, this will be useful for predicting the dart, right? Let's say if I'm playing against the world-class player, okay, and this is our first 10 try. Now that you plot your distributions, your task is to predict which one's going to win at last. Okay, now that you have the distributions, you can start to do predictions. And obviously, because his distributions is way more focused, he has a higher chance to win. Okay, but we don't predict that competition every single day, right? But we do all sorts of predictions. Let's say you're an insurance company. Okay, you're predicting which airline is going to crash. Okay, then every airline will have a distribution like this, and you can calculate the probability of, okay, maybe Cathay Pacific has a very accurate distributions. It's not gonna crash, but maybe some, I don't know, Vietnamese. No offense to Vietnam, but yeah, some dodgy airline might have a very flat distributions. And that way, you can start to make predictions. And that way, you can start to, make an educational guess of the future. Okay, I hope that makes sense. So, statistics is important in some other ways. So, this is a very interesting website called 538. Okay, this guy is brilliant. Okay, this guy is called Nate Silver, and he successfully predicts who's going to win the U.S. champion. No, U.S. president. Okay, obviously he hates Donald Trump, and okay, he plotted out how Donald Trump compares to the other president. Okay, if you roll down, the line below is the popularity of Trump. And he is comparing the popularity between every single president in the US. And his understanding is going to prove it statistically. Donald Trump is the worst president in history. But if you do it this way, it's quite scientific. Okay, you can have a look. George W. Bush, you can see in here you have a line that Bush up a lot. Okay, that's after 9/11. Okay, so everyone started to support Trump. And in here you can see it's 4 days, which is exactly how many days Donald Trump has been a president. But you can project it for 8 years. Okay, and you can see George W. Bush, even though it rise up a lot higher in 911, it just go downwards afterwards. Okay, so this is just a example of how we use statistics and how statistics can be useful when compared across time. Okay. Okay, so some useful tips for statistics. It gives us the big picture of the reality. It sort of proves your concepts in science. Let's say your hypothesis is Donald Trump is the worst president in the world in history. Then you can statistically compare it with the previous president. Okay, that's useful. It also shapes the angle of how we see things in a society. I think that's very important. Let's say I show you this image. Okay, can you tell me one thing about this image? What's the most obvious thing you would tell me?
Yao Ming.
Sorry?
Yao Ming.
Yao Ming. And what's so special with Yao Ming? He's tall, right? Okay, but why is he tall? Why do you think he's tall?
He's the basketball player. Everyone else in the
People are short.
Yeah, I think
Occupation.
from this image, he's tall because other people are shorter. And very obviously, he's way taller than the average. Okay, that's one thing. And this tells us one thing, is every single concept or every single adjective you can think of is relative. Okay, why do you think Yao Ming is tall? Because you know the average people is around 1.7. So 2 meter is definitely very tall. Okay, because we have these concepts. But let's say if you compare Yao Ming with building, you won't say Yao Ming is tall because physically a building is taller. But okay, let's say we go back to a computer. Computer have no concept of what's a tall person. Okay, if you plug this whole thing into a computer, the computer won't understand Yao Ming is a tall person because computer doesn't have a concept of the average human height. And we do have this concept because we see human being every single day. Okay? This concept can extend to any adjective like weak, strong, deep, powerful. Any of these concepts are relatives. Okay? Alright, so let's go to an example about height. Okay? Okay, what I'm doing here is I import 3 libraries. NumPy is the package we're going to talk about today. Pandas is a very powerful data managing software that basically put Excel sheets in Python. Okay, and then Matplotlib is just a plotting library. And in here, I'm basically reading data from the internet. Okay, if you just copy this URL, paste it on your browser. Okay, sorry. Okay, it's gonna download a CSV, and you can have a look. Sorry. Okay. Okay, I didn't have Excel, but I can open it on a free software. Sorry. Do you want to cancel? Okay. Okay, this is the datasets. Basically, this dataset has the BMI, has the sex, has the education level, and obviously we have the height and the weight. Okay, this dataset I got it from online, and it has like 4,700 rows. Okay, and now I'm gonna show you how to open it on Pandas. Okay, basically all you need to do is just pd.read CSV, and you can define this whole data into a variable. So from now on, height is the document you just saw. Okay, now you have spreadsheets in your pandas, okay, in your IPython notebook. And because we care about height, we want to find out what's the average human's height and whether Yao Ming is way taller than the average people.
Sorry.
Yep.
But for me, it's not loading NumPy.
It's not loading NumPy.
There's no module named NumPy.
Okay.
We have to use
Yeah, you have to install the library.
Okay.
So, are you using Anaconda?
No, I'm just using the
Okay. That way you can do it by exclamation mark pip3 install NumPy.
Okay.
Okay. That's the easiest way to install a library. Okay. This might not work for everyone, but that's the way on how to install the library. Okay. Any other questions?
So what output are you getting there? Because I'm not sure it's in the sense that
You mean you
well,
can't?
You're running the script, yeah, and then you have the spreadsheet.
Oh, so the spreadsheet didn't show up in your.
No, I don't have anything. I've got the code here, but I don't have it.
Okay. If you want the spreadsheet to show up, just first key in the first three libraries. So it's NumPy, Pandas, and Matplotlib.
Okay, yeah, that's already in the.
Yes.
Yeah.
And then all you need to do is to execute the sixth line. Height equals pd.readcsv. And then is that working for you? Okay. If you don't know where to copy the code, it's just right under the Yao Ming photo, and you can see a whole long piece of code. Does it work for everyone? Okay. Okay. If you have question, I'll come over at the break. Okay. Alright, so now what we want to do is we want to statistically find out if Yao Ming is really a tall person. So the obvious thing to do is to compare the height of Yao Ming with the general public. Okay, because now I have a very big data set. I have like 4,000 people's height. I can plot a graph and I can see in which position is Yao Ming. Okay, so what I need to do is I have to find out the average height of the data, and the way to do it is basically np.mean and then key in the height. And in here, height.height basically means getting the height column in the spreadsheets. Okay. Okay, that's basically getting one of the columns. Okay. And then you can do np.mean, and you can find the mean of the average persons. Okay. Okay, and what else do we need? If we want to compare someone height with the average, we have to also find out the standard deviations. So basically, just do height.height. Okay, and you got these two informations. You have the mean and you have the standard deviations. And now that once we have the this is so-called parameter of the public's statistics, we can plot a graph based on the public. So the way to do it is this. Okay, you do np.random and you plot it into your normal distributions. And you simulate the result for 10,000 times. Okay? And then if you run the code below, it's gonna plot you a graph. Okay, basically this is what the data tells you. And if you look back to the height of Yao Ming, Yao Ming's height is 91 inches. And you can compare the graph, and Yao Ming is right here. Okay? So now you can tell, okay, Yao Ming is a very tall person. Okay? Any questions for here? Alright. Okay, the next thing we're going to discuss is statistics versus data science. Okay, so you might think statistics and data science is very related, and some people might think it's the same thing. Okay, but if you go to like a data science work environment, you'll realize these two teams of people hate each other. Okay, like back when I was working in Jockey Club, the stats people hate the machine learning guys, and the reason for that is because the two things is quite different. Okay, if you have a stats background, what you need to do is you have to go onto every variable and then carefully look at the variable. Okay, is this statistically significant? If not, I'll just cut it away. Okay, but if you are data science guys, all you need to do is to put as much data into the model until it reaches the best predictions. So it's a very two different mindset. One is a very hardcore science, that's statistics. Find out, okay, the correlation of this variable, is the shorts going to affect the goal, etc. But data science guy doesn't care. Okay, just put everything into the model and just optimize the results. Okay, so that's two very different mindsets. Okay, if you are interested to debate, there's just some further reading. It's basically a forum and a lot of people shouting at each other. But yeah. Okay, so today we're gonna talk about a library called NumPy. Okay, NumPy is basically number with Python. And from this point onwards, we are drifting away from the proper, hardcore software engineering Python. We are gonna do something very data science focused. Okay, so what's NumPy? NumPy is basically an ecosystem. Okay, and a lot of these libraries are used by scientists. Okay, we have pandas, which is the spreadsheets looking library. We have scikit-learn. Okay, make sure you remember scikit-learn because this is what we use for machine learning. And we also have matplotlib, which is the plotting library, and we have NumPy. Okay, so what's so special with NumPy is NumPy is very fast. Okay, if you use Python, Python is actually a pretty slow language because Python is built on top of C. Okay, so it's something called an interpreter, and every line of Python you type in, it will somehow translate to C and run it in C. Okay, so imagine every line of code has a translation process. It's going to be very slow. But what NumPy does is it just skip that process and run it directly in the fastest language. Okay. And in real life, what's NumPy is involved? It's involved in all sort of things that requires a lot of calculations. Something like image processing, because okay, when you look at an image, it's actually a lot of pixels, right? And think about what's a pixel. a pixel is 3 numbers of red, green, and blue. Okay, so now if you have an image with 8 million pixels, it's 8 million times 3 numbers. It's just basically a lot of numbers. So when you have that much number, you have to have a very fast machine to process it. Okay, so NumPy is used for image, and it's also being used for natural language processing. Okay, a lot of time. Okay, so why do we use NumPy? It's because it's very fast. And I'm going to show you how fast it is. So this is just an experiment. I import a library called datetime, and what I want to do is I want to calculate the sum of, I think, 1 million numbers. Okay. So now the top one is calculated using NumPy. The second one is calculated using the normal Python list. Okay. So just run it. The two things happen instantly. So what I do is I calculate this. I record the start time and record the end time, and calculate how long does it take. So NumPy take this much of time. Python takes this much of time, and NumPy is 14 times faster than the average Python. You can do a lot of these tests. So this one is to find a minimum out of 1 million numbers, and NumPy is 21 times faster. And the other one is NumPy versus Python in creating a 10 times 1 million matrix. Again, okay, this is gonna take a little more time. So Python takes 2 seconds, but NumPy is 14 times faster. Okay. Okay, so now this gives us a lot of reasons why we should use NumPy. Okay. But usually in our day job, we just do everything in pure Python. And if we want to optimize the thing, we use NumPy. Because, okay, in my day job, we have a very large data sets, like the entire Amazon is in our computer. And to run the model, it probably takes like 9 hours to run it. So now we can use NumPy to optimize it. Okay. And this is very important. Just basic operation using NumPy. Make sure you download the list and have a read at home. Okay, this is all the syntax you need for NumPy. And if you're new to programming, I think the best way to learn is to find a problem to solve and check this cheat sheet whenever you're stuck. Okay. And here's a link for a high definition version. Okay. Okay, the next thing we're gonna do is try out with NumPy. Okay. If you're not very familiar with the concept of a library in a programming language, what exactly is a library? Is okay. Imagine someone in the world has written a lot of code, and he wants to share the code to the public. Okay, so he pack it into a library and put it online. Okay, now whenever you download his sort of package and import it to your Python code, you do it this way: import NumPy plus np. Okay, what this sentence means? Import means importing a library. NumPy means name of the library, and this guy's behind is just basically, I don't want to type NumPy every single time, so I just call it np. So it's just easier for everyone. Okay, then from now on, everything after np can be called. Okay, if you are new to programming and you don't know, okay, what can I call from NP? You can do dir, which is a directory. So put dir and np, and you can find a list of functions that's underneath np. Okay, and if you are not really sure, I think you can do np.arange and then question mark. Okay, once you're not very sure with any functions how to do it, just put a question mark and Python's going to help you out. And here's like all the explanations on how to use it, even an example. Okay, let's say this example. And the best way to try it out is just np.arange, and it's just going to show you how it works on the code. Okay. Alright, so let's say I have a very long list of mean, 1, 2, 3, 4, 5. Okay. Just to find the mean is just do np.mean, and then you can find the mean of it. Okay, that's how simple it is. And let's say if you want to do calculations, let's say I have a variable called height. Okay, height is our our spreadsheet-like data structure. This gives you a long list, and let's say I want to do the mean of it. I just do np.mean and then height.height. Okay, let's give us the average. But let's say I want to convert this list from inches to centimeters. How can I do it? Okay, if you do it without NumPy, just do times 2.54. Okay, it still works. But if you put it into a NumPy array, it's going to be faster. And usually it's cleaner as well. So that's the average height in the centimeters. Okay. Okay. And if you're confused between a NumPy array and a list, the two things operate very similarly. But just that if you change it to NumPy array, everything becomes way faster. And it's easier to do mathematical operations. Okay, so let's say I create an array called 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And in this case, I can do x plus x, and the two lists. Okay, now I define it. Okay, if you do x plus x, the two lists gonna sum up. But remember, last time we talked about list. If I do a list plus a list, what's gonna happen? A list plus a list. It's gonna concatenate, right? So NumPy is different. Okay. If you want to do maths, use NumPy. Okay. Okay, here are just more example. Okay, now I have an exercise for you. Try to perform maths on a height dataset. And I have 3 questions for you. Convert the height to cm. Find the mean, mode, and median. Okay. You might need to search online for mode. Okay. And I'm gonna help out. You can copy this out. The entire line of here. Everything upwards. You can copy or cut. And then you can press A. Create a line. And then just paste it in. You can just control or command E. Maybe just copy again. Copy. I'll just try. Actually, I think you have to highlight. I think you have to use the keyboard. Control C for or Control X to cut it. I think maybe you have to do command X. Yeah, and then command V. Then you can do Control Enter or Shift Enter. Now just try to type height here. You can create a new cell. And then Shift Enter. Oh yeah. Should work. There you go. Some error. Okay, this outlook.因為咧 Mac 機咧有呢個問題嘅，可以 send 你要重新裝個某啲 library 先至 work 到。咁嗰一刻方便。係啦，最好 highlight 咗佢。如果你download 佢同一個 folder 咧，你就可以直接 read 呢個 file。再唔係我 send 條 link 俾你，雖然你係叫咩 email，我揾翻你個 email 先俾佢。 basically 就係 read 翻呢個 file 本身係同一個 folder，佢就會讀 folder。有奶茶。
Yeah, this is it's fine, such a that's how a program is. Like, just try how to remote.
Okay, if you're stuck with mode, my advice is try to Google. Okay, because NumPy doesn't have mode. Alright? Hey.
我要自己揾呢個用嘅。
你應該就咁 Control Enter 就揾到，即係呢個呢個係條 link 啦。咁你咁樣咧，其實會着佢太大啲。
但係我自己呢一個係我自己喺邊度去
佢揾呢
登
個
咯，係咪？
哦
係咩丁行定
其實咩你頭，總之你條 link 係咁，佢就係 download 到嘅，就可以咁樣變。係，實際我揾埋俾你。
Yep.
So it's basically the running all this.
Different data type.
Oh, it's just so not really convert type data into
That's the NumPy version of the high data.
Oh, so what's here?
I think the difference is just to use the bin in the NumPy package.
Yeah, so it's just again that rather than Python.
Python.
How to do mode. Okay, so okay, let's try to do it. Okay, the first step is basically just run what I gave you. Okay, so I gave you the height, right? And if you run the height, okay, now it gives you a vertical long line of thingy. Okay, you can think of it as one of the columns. Okay, if you find a type, in Python, how you check the data type is do this. Type height. Okay, you can see it's a pandas call series. Okay, it doesn't matter what it is. It matters that it is not a NumPy array. Okay, so now we have to change it to NumPy to make it faster. Okay, and how we do it? It's just np.array and height. Okay, now everything become way faster. Call it height. So I override my previous height by creating a NumPy array with the same informations. Okay, now that we have height, the first question is to convert it to cm. So basically just time 2.54 and become height in cm. Okay. Okay, now that we have the height in cm, we can find the mean of it, and you can do it with the NumPy package again. So just do np.mean and then height in cm. Okay, now we have the height in cm. Okay, for the mode, it's tricky because NumPy doesn't have a mode. So I'll skip to the fourth question for now. So the fourth one is easy. Just do np.median and then height in cm. Okay, so you can find median is 170. Okay. Okay, so now back to our third questions, how to do mode. Okay, let's say you finish our course and you're stuck in programming and you have no one to ask for. It's a very common situations. And Google is your friend in here. Okay, but what should we search on Google? I would suggest always search Stack Overflow. Okay, if you're a programmer or if you're like a software related stuff or guy, you go to Stack Overflow every single day. And basically what's just Stack Overflow is just a forum. Okay, it's a forum for you to ask questions. But you know, all sort of problem, if you're a beginner, is being asked on programmer. So if one day you realize you're stuck and your problem has not been asked, then congratulations, you are a very good Python programmer. Okay. And basically, a lot of software developer basically just copy each other's code online. That's how they make money. Okay. So let's try to solve our problem. Stack Overflow, Python, how to use mode. Okay, then the first one, Python, find the mode of a list. And then the very handy thing, it's the best answer is voted. So the best answer usually comes first. And you can just scroll through all of them. Okay, I find this the most understandable. So I just copy it from statistics, import mode, and then there you go, you can try it out. From statistics. Okay, if it works for a list, this should work for our NumPy array. Okay, there you go. Okay, I don't think of it as cheating, because this is the standard practice in coding. You copy code a lot, especially as a beginner. Okay.
So the from statistics, that is what? That is
From statistics, it's a package.
so, okay, so you're just importing as a function from the
Yeah, so some people on Earth return these functions, put it online, and you just reuse his code. Okay. There are some other way to do it without another library, probably this one. But by looking at it, it's not very intuitive. So it's your choice which one you choose. Okay. A lot of different ways to do it. Okay. Okay, don't worry about copying all the code I wrote, because I'll send it back to you after the class. Okay. And okay, one thing with NumPy is it can be in different shape. Okay, so when you talk about a Python list, let's say this is a Python list. Okay, we all learned this, but for Python, you can do something very tricky called a list of lists. Okay, let's say this is 3 lists, and I can put all of them inside a bigger list. Oh, sorry. What's wrong? Okay, I'll do it again. 1, 2, 3, 4. Oops, sorry. 1, 2, 3, 4. Okay, this is a list, and I call it X. And it can be done this way. X, X, X. And it becomes a list of lists. Because every item in the list is another list. Okay? And we can further expand this guy and become a list of lists of lists. And then we have a headache. Okay, it's so complicated. Okay, NumPy is easier for doing this kind of stuff. And this case I just mentioned is very useful in real life, because every image you saw is a list of list of list. Because every pixel, okay, let's visualize a pixel. Pixel, okay, not this one. Pixel number. Okay, pixel visualize. Okay, this one is better. Actually, this one is better. Okay, every image you saw online is something like this. Okay, it's basically a lot of tiny box, and every boxes has different color, and every color is involved in 3 numbers. So it would be a 2D image with a 1D array on top of it. Okay, so it will be a complex matrix, if you see what I meant. And then let's go back to NumPy. For NumPy, you can do a 1-dimensional NumPy, or you can do a 2-dimensional NumPy, or you can do a 3-dimensional NumPy, and there's no limit. You can keep going until your computer explodes. Okay, and and in here you can see all the shape. Okay, in NumPy, if you do dot shape, it gives you a few numbers, and that shows you the dimension of your array. Okay, so this is just an example of assuming we know the mean of the income of the entire Hong Kong is 50K. and the standard deviation is 10K. That's a very naive estimation. But let's say I want to simulate the distribution of the Hong Kong people's income. So I just put 50K, 10K, and I repeat the whole thing for 10,000 times. And okay, that's my income. And if you do it this way, that's the mean of my simulations. And this income, it's my simulated very long array of Hong Kong people's income. Okay. And if you keep running the code, it's gonna show you simulations. Okay, so that's assuming our parameter is correct. That's the distribution of the Hong Kong people's income. Then probably you can try to look, okay, I'm right there, and you can calculate where you are, okay, in the Hong Kong people's income. Okay, let's say I have another exercise for you. Try to do what I just did, and did it for the simulation of distribution of weight. But before that, do you guys understand what's a simulation? I forgot to talk about it. Okay. Okay, I'll give you a more intuitive example. Let's say you're betting. Okay, betting World Cup. We have a lot of teams, and you want to know the probability of Brazil to win the World Cup. What can you do? You can't build a deterministic model for that. But what you can do is you can give some sort of probability for every team and say, okay, in a parallel universe, if the World Cup happened for 1,000 times, how many times Brazil is going to win? Okay, does that make sense? And if you count on that 1,000 times, Brazil won 200 times. That's 20%, right? So probability of Brazil winning is 20%. And what I meant by simulations in here is, now I know that the average Hong Kong people have the income of 50K and a variation of 10K. And I keep on generating this virtual Hong Kong people. I generate it for 10,000 times. Okay, now I have a lot of virtual Hong Kong people lining up in front of me. And I'm counting how many of them have an income of 50K, how many of them have an income of 10K. Okay, that helps us to plot a distribution like this. Okay, if that doesn't make sense, let's go back up to our very first example, these guys, because this is the most intuitive one. Okay, if I'm doing simulations, all I do is after you have thrown the first 10 dice, and then I will simulate or project how are you going to throw. Okay, if out of this 10 dice you have a mean of 2 and a standard deviation of 3 or 4, then every single point I simulate will be very similar to this. I hope it makes sense. Okay, so simulation is just like repeating what you are supposed to do on a parallel universe. Okay.
This is a Monte Carlo, right?
Yes, a Monte Carlo. Yeah. If you don't understand what's a Monte Carlo, try Wikipedia. Monte Carlo simulation. Yeah, just read it. that's the best way to learn.
I'm just saying we're just going to rinse and repeat the same thing, is what you're saying.
Yeah, repeat the same thing. but you have a assumption that your parameter is true.
So we're like, making an assumption, and then based on this assumption, we keep, for an easy way, just we're keep looping to do the same thing again and
Yes,
again,
yes.
and collecting the data to follow graph.
Yeah. So basically, a simulation is just an easier way to plot it out and look at it. Okay. Okay. As long as I keep going, you would start to understand more. Okay. Do you guys need a break? Like 5 minutes, or is that okay? 5 minutes. Okay. 5 minutes break, and we'll come back.
So basically within 50 plus or minus, we keep doing it like 1,000, like 10,000 times, and if we record all the numbers, it's half that we something like that.
And the nice thing with the graph is, let's say you wanna know the weight of people, and you go out on the street and you survey 50 people. But then the graph will look very
Different
because you don't have enough data. So this is just a way to have a first guess of the populations and try to trust that parameter for data.
So it's more like after, like for example, we take the 50 people we found out,
Yep.
and then so we would know, we can make an estimation of what the standard deviation is and what the average is.
Yep.
And then we can say, oh, okay, we want to know this number bigger, and then so we can do it like different times of all the times.
Yep.
So we can extrapolate the data we already have and make it larger. Is it an example of I know it's not, that won't be perfect, but it's something like
It's something similar. It's more useful when you don't have enough data.
Yeah, so the problem that we got with so for some things are also college, and what is that more joy or to repeat the what's pattern. So
Also, we upload the Saturday. Number you
So you said
just mean standard deviation
so
and the number of simulations.
so basically that node. So we say it with the name and so since it's normal it's going to
Yeah, very shape.
okay. And we understand the division because
Like how, like the dispersion. Yes. Yeah.
yeah, but there's another division.
What do you mean?
If it's not maximum.
Oh, you mean the outlier, like the max? Yeah, it's not. Standard deviation is like there's a formula for it, but that describe how diverse, how like a range. Let's say the range. If a random, you pick one random item out, how much would it vary? Probably.
So,
Variation.
yeah. Change for
Yeah, but if this number is small, then it's gonna stick to the mean.
yes.
But if big, it's gonna be
Yeah.
OK，我有第二first part 係講翻上次你講嘅我都係做翻上次呢啲問題。呢條可以，我擺上 YouTube。好，會 send 俾你哋嘅。
If you're back, you can start working on the exercise 3.05. Okay, I don't want to finish late today, so I'm gonna rush through the rest of it. This is the answer for the questions, and how to get the distribution of weight. Basically, just do what the previous exercise does. Just do np.random.normal. You put the mean is 175. Standard deviation is 50, and then you have the number of simulations, and then you do plt.hist. This line means using the library of plt, which is a plotting library called matplotlib. Okay, and then .hist means plotting a histogram. Okay, if you don't understand the code, just run it. Look at it. So look at what weight means. Weight is just a numpy array. Okay, and then if you do plt.hist on the array, it's gonna plot you a histogram. Okay, for a histogram, it means plotting out the distribution of it, and the way to look at it, the y is the quantity, and x is the real value. Like this is 200. Okay, weight 200 pounds. This is weight 50 pounds. Okay, and this literally means 600 people weighs 175 pounds. Okay, and in here you can see there's a number. That's the number of bins. Okay, try to look at the histogram. Now the edge of it is quite is not very smooth. If you increase the number of bins, the histogram is going to be smoother. Okay, now you can see it's plotting a very detailed graph.
Okay, so what does the bin mean?
Okay, the bin means, let's say now you have a range of from 0 to 300, right? 50 bins means every bin has a width of 6 in here. And then whatever people that falls into the bin, you count how many people are there.
Okay.
So if you have more bins, then the whole graph will be more refined.
Okay. So it's making the like the bar size thinner and thinner.
Yeah, the bar side thinner, and that's a way to make the histogram more detailed. Okay. Let's say if you only put three bars. Okay, the histogram is going to look like this. Okay, increase it to 10 bars. It's going to look like this. Okay, and all the nice looking graph you saw in textbooks has a very large number of bins, like this. Okay, hope that makes sense. Okay, now there's one interesting fact. So most of the time, mean is not very reliable. So let's say a very rich guy, say Bill Gates, or I don't know, Li Ka-shing, just joining the population of Hong Kong, and basically has way more money than everyone. Okay, let's say I add in Li Ka-shing, and he has that much money per month. Actually, that's an understatement, so I just put more 0. Okay, and then try to plot it out. Okay, the average income before he joins is like 50k, but right after he joins, the average become much bigger. Okay, because basically he is too rich, and he just distort the entire distributions. Okay, now that after Li Ka-shing joins, if you plot it out, the graph gonna look like this. Everyone in Hong Kong will be on this side, and Li Ka-shing will be right there. Okay, then this graph doesn't tell you anything. Okay, so the better way to do it in this case is try to cut the outlier. Okay, try not to involve Li Ka-shing in our game, or you can do something different. Try to get the median. Okay, so the median stays the same, but the mean is seriously distorted. So try to be clever and check if there's any obvious outlier in your data. Yeah, so basically that's just well, if there's an outlier, use mode or use mean. Okay. Just run it. Okay. Okay, and I'm gonna just briefly talk about variation and standard deviation. You probably heard of the term, in high school, and you quickly forgot what's a variation and what's a standard deviation. Well, I'll try to talk about it without mentioning all the formulas, but try to think of it intuitively. So let's say back to our okay, let's say now you go down on the streets, you try to pick someone out. Okay, try to ask a random pedestrian the weight Okay, every pedestrian you picked would have different weight. And what variation means, how much difference are they? Okay, let's say if you go to like I don't know, like a nightclub. Okay, everyone is very fit, very thin. Okay, the variations is a lot smaller. But let's say you go to, I don't know, McDonald's. Okay, probably, actually the variation would be quite small as well, because everyone goes to McDonald's might be overweight. But if you pick it like, I don't know, go to Causeway Bay, pick someone out of Sogo, okay, because Sogo is a lot of people, and that population is sort of representing the entire distributions. And then the variations in that case means how varied are the samples. Okay. And okay, this is just another way to help you understand what's the distributions, what's the probability distributions. Let's say I've written a speed test. This speed test is the same as what I just showed you a few slides ago. Okay, but I don't know if you realize every speed test gives you different results. Okay, let's say you define functions and then you test the speed. Let's say you test it one time and then it's gonna give you this number. NumPy is 5 times faster. Okay, and if you really want to do like a proper recording of a distributions, try to run this test for 500 times, and then you can get a lot of tests. Like NumPy is 5 times faster, 10 times faster, and if you repeat it for 500 times, you're gonna get a distribution like this. Okay, so that's how my computer performs. So you can see on average, NumPy is 11 times faster with a long tail. Okay. Alright, so after that I have one pretty interesting question to ask you guys, because when I was in high school I don't understand why normal distribution is bell-shaped. Okay, and I'm gonna give you a proof of why is it bell-shaped. So let's say this is so-called a uniform distributions. Okay, let's say I give everyone in Hong Kong a dice. Okay, Hong Kong has 7 million people. Everyone throw a dice. What's the outcome distribution look like? Everyone throw a dice. Yeah, it's gonna be uniform, right? Because the chance of getting 1 or 6 is the same. Okay, it's gonna look like this. Okay, now I give you another example. I give everyone in Hong Kong 10 dice. And what's the distribution looks like? And everyone get 10 dice, and you just sum the amount of that 10 dice. What's the distribution is gonna look like? It's gonna be uniform. Okay, so here's a way to prove it in programming. Okay, that's the population of Hong Kong, and that's basically okay. This function is just randomly generate a number out of 1 and 7. Okay, so this is just a simulation of every single dice that's being thrown. And if you do it linearly, like everyone has 1 dice, you got a distribution like this. Okay. And if you want to do it differently, basically you just replicate this line for 10 times, right? Then it will no longer be a one long array, but something like not a matrix, but like spreadsheets. Okay, it's gonna look like it's gonna look something like this. So you have everyone from 10 times, and then this line is 7 million long. And for every operation, I just sum the amount up here. Okay, so the first step is to generate a graph, a table like this. So what I would do is basically this. So first of all, I generate a very long list like this. Okay, that's 70 million. Okay, and I do something called a reshape. A reshape means I just play around with the shape and say now I give it 10 rows and 700 million columns. Okay, and then in this case, when I do dot sum axis equals 0, it just means I'm doing this sum. Okay. So in Python, axis of 0 means the row, axis of 1 means the column. Okay. And then, okay, if I do this, and basically I just bound the whole thing with the histogram that we just learned. Okay, I'll just put it right outside and give it a bin of 50. Okay, now that you run it, because I don't know how long would it run. Okay, it gives you normal distributions. Okay, so if everyone in Hong Kong floor dies and sum it, it's gonna give you a normal distributions. And then now you can think of it why. And think of it intuitively. Normal distribution happens on natural world. So a lot of natural events, or let's say you count all the cats' weight, is going to give you a normal distribution. Or you count the height of everyone, it's going to give you a normal distribution. And that's because when we grow up, a lot of different random event happens. Okay, and these random events add up, just like all the dice, gonna give you a bell shape. Okay, that's how the world works, and that's a way to prove it programmatically. Okay, hope that makes sense. And this is just different way of plotting the graph, and you can look at it at home. And the other thing I want to talk about, it's called the exponential distributions. Okay, if you keep on working in data science, not many data sets is normally distributed. A lot of them are in different shape. So one example for exponential distribution, it's when some news go viral. And let's say I post something on Facebook, 2 of my friends saw it, and they posted on Facebook again. And then more and more people saw it, and this event is something called exponential, okay, exponential distributions. And if you want to simulate that pattern, you have to use a shape like this. But that's just for your information, okay? Binomial is something else. It's just like throwing a coins. But if you repeat it for many times, it's going to give you a shape very similar to a normal distribution as well. Okay, that's called Poisson. And you have the percentile. Okay, does everyone understand what's a percentile? Okay. Yeah, very similar to percentage. So what the percentile really means is, let's say this is the distributions. Let's say this is height, and Yao Ming is right here. Percentile means how many people did you beat? How many people is Yao Ming taller than? If his percentile is 99%, means he's taller than 99% of people.
Wouldn't that be similar just for all the examples so instead it'll be like 0, so in that table here.
Yes.
It'll be 0 to 100?
You mean this axis?
Yeah.
This axis is the actual value.
Oh, yeah.
Yeah. So if you go to the Yao Ming example, this is Yao Ming. Okay, look at the x-axis. This is the height. Okay, and what's the y-axis?
Oh, wait, would the percentile then be like a curve that goes up? Like if we're to change the x-axis into percentage or the percentages, it'll be something like that.
Okay, if you add up every single one, it's gonna be a curve like this. But because you're not adding it up, so it's a bell shape. Okay. Okay, I'll ask you guys a question. What's the y-axis?
Frequency?
Yeah, number of sample and frequency. It's the same thing. So what this means is if I have a lot of basket, okay, in here I have 50 basket, and imagine if your height lies in that basket, you just put a vote, okay, put your name in the basket, and then this is basically count how many names are in the basket, and that plots you out the histogram, and that's what it means by distributions. Does it make sense? Better to visualize it. So let's say I have one axis, and this is height, 100 cm to 200 cm. Okay, and every 10 cm, I put a basket, and everyone comes, and then, okay, if my height is 170, 170, 180, 190, 200. Okay, whenever my name lies, or my height lies in one of the basket, I just put my name in here. And if your height lies in here, just put it in here. And all of this add up. Okay, it's a very bad drawing, but it would be a shape like this. Okay. Hope that makes sense. And okay, let's go straight to 3.2.8. Okay, I'll delete this. Okay, let's look at real data sets, which is the salary data sets. Okay. If you run the line again, it's 3.2.8. Okay. Just run the box again and check DF. Okay, now this is a different data frame. Okay, DF stands for data frame. Okay, Okay, that's the standard practice of calling a data frame. And you can see in this Excel table, we have like age, work class, education, maternal status, occupation, etc. So basically this data frame is got from like a government website, and this is quite a huge data set. It has 48,000 rows and 15 columns. Okay, next class we're going to talk about how to effectively use pandas, but I will quickly show you how to use it. So if you do df.shape, it's going to give you how big is the data frame. And if you do df.info, it's just going to show you a description of the entire data sets. Okay, like the data class, if there's any missing value, etc. But let's focus on the data set itself. Okay, so the tricky thing for any data sets is you can look at it without prior knowledge or with prior knowledge. Okay, what prior knowledge means is, do I have any knowledge before I've seen these data sets? And there are two different approaches for looking at a new data set. One is, okay, I have some assumption, say I see educations and I saw the income. And I assume that the higher the educations, the better the income. And my approach would be proving my hypothesis. Or alternatively, we can try to find out the pattern of the data sets. Okay. So let's say I assume I have some bias. I think the better the education, the higher the salary. Okay, so that's how I plot it out. Okay, in every df.education, give you all the education of the datasets. Okay, and if you do df.value_counts, okay, that just help you to count the distribution of the people. And you can see a lot of them are high school graduate, and some of them has bachelors, so the majority of them are high school graduate and only have very few doctors. Okay, so if I do it this way, sorry. Okay, maybe I'll further explain what I'm doing here. So let's say DF education. I want to check everyone who is a high school graduate. I put HS grade. If I do this, oh sorry, HS, yeah, education. Okay, if I do it this way, it's gonna give me something called a boolean. So it's either show you it's false or it's true, like whether or not this is a high school graduate or this is not a high school graduate. And if I bound the entire thing by a square bracket, it acts a bit like a filter and give me the data frame with only the high school educations. Okay. And then let's say if, okay, this is actually the salary, FNLWGT. Okay, in this case, if I just take this column out, then basically I have the distribution for the salary of all the high school graduates. Okay, and that's my distribution for high school graduate salary.
I don't get,
Yeah.
so the bracket is, so the bracket of the education equals to high school graduate, that filters out, like the first part filters out everyone that's a high school graduate.
If
Like,
you
at least the part that one you have there.
yes,
And
okay,
then once you square bracket it and put a DF in front of it,
yes,
that basically just filters everyone that's a high school graduate.
yeah, it only shows people that has a high school graduate.
And once we put a dot FNLD, the
Yeah,
weight,
yeah,
with that we'll then just show all the weights of everything you already filtered. Is that what you're
yes,
doing?
yes. Okay, maybe we'll go through this next class, but let me do it slowly and show it again. So for DF, we have the entire datasets.
Yeah.
Okay. And to choose one of the column, let's say I care about education. I do dot education, right? Now I have a column of education only. So now if I care about high school graduate only, I try to find out only the high school graduate. Okay, let's give us a true or false. A very long list of true or false. Okay. Okay, now the tricky part is if I do this, basically I'm applying this true or false on my data frame. If the row is false, I'm not gonna show it out. If the row is true, I'm gonna show it out. So it's like a filter. Okay, so once I click it, look at the data frame. All of them are high school graduate. Okay. And now, if I pick one of the columns, then they will be the salary only for high school graduate.
Okay. Is that the salary?
I think that's the salary. That's not the weight. It's like financial weight or something. Yeah. So now I have the all the data for high school graduates' salary. Okay, now I can call it. Actually, you can do it without the list. So I just call it high school HS. Okay, I call it HS. Oh, sorry. Okay. Alright, so let's say I repeat what I just did for high school graduate, bachelor, and master. And if you want to plot multiple things into the same graph, you can basically repeat the line. Just keep doing plt.hist for different education level. And then
What is the FN?
oh, this one.
Yeah, what was that?
Okay, look back into the data frame.
Oh, okay.
That's the column. And actually, it's just a very bad naming for the salary. Okay. And so now you can plot the distribution for salary for a high school graduate, which is this color, and bachelor and masters. And the blue one is just the general public. Okay, so I'm gonna ask you what this graph tells us. I'll make it bigger.
They didn't show the bigger legend, so
Sorry?
the red one is stand for one.
Oh, sorry. Okay, the red one is masters.
Or how do we know? Oh,
Yeah, just by the sequence. Actually, just by common sense, because master has less number than bachelors.
Is there a way to show the figure ledger?
Yes, but I will teach that 2 class later. Okay. But just to test your understanding with histogram. Okay, what's this class? What this graph shows us?
That there's very little people doing masters, and then there are more people do bachelors, more people do graduates than everyone else.
Yes. How about the distribution for salary?
Salary, that,
The x-axis is salary.
yeah,
The y-axis is account.
that there's actually very little,
Yeah, just very little difference.
there's very little difference between all the item jobs. Doesn't matter.
Yeah. So education doesn't really matter in this case.
Actually, I'm not sure about something.
Yeah.
For the blue line is everyone. So does it mean like for if I was to take one bar, that would mean it's the red bar plus the green, like the blue bar equals to the yellow bar plus the green bar plus the red bar.
Well, if you have all the education types,
Yeah.
then it adds up
To the blue
to
bar.
the blue bar.
Okay.
Okay. But because we didn't add every education.
Yeah.
Does it make sense for other people? Okay, a lot of people got confused because it looks like the blue one has the highest salary, but that's the frequency. Okay. And one other interesting fact, if you go to the data frame, okay, and do a histogram on age. Okay, common sense, age should be normally distributed, right? Try to plot it out. The age looks like this. Why? Why does the age looks like this? More young people.
The older you are, the more
It's the Latin population.
Nope. Why there's no one younger than 18?
because they don't make a profit before they are an adult.
Yeah, because they are not allowed to work legally. That's the reason why the graph is biased. Okay. The point I'm making here is if you do data science, the number lies. Okay, every sample is biased. Okay, and don't try to look at the number and trust all the number. Try to think of it intuitively. Then everything starts to make sense. Okay, and then well, correlation and covariance, I'm going to talk about it when we have our regression class. And okay, probably we'll follow this up next class. And before you go, I have one thing to show you, which is this. Okay, if next Monday you're gonna hand in your hangman homework. Okay, if you haven't started or you don't even know how to start, I'll try to go through this example. Because I try to break down the hangman into smaller parts. And if you just follow the example and do the questions, hopefully it will make sense to you how to complete the questions. And if hangman is easy for you, do the maximum substring problem. Okay? And okay, we're on time today. Thank you guys. That's it for the class. Thank you.
So, I'm sorry,
Yeah.
if you don't have all the class, do we still listen?
Yeah, try to do the maximum substring.
Yeah, should we just send the timeline we did before?
Yeah, just send me. Yeah. Thanks.
Thank you.
Thank you.